All right, thanks. And if anybody has any questions, we can have those at the end of the session. Before we get into the next session, as you can see that, in the course of just a couple speakers, we've used a lot of acronyms, and we understand that, right? And so I've heard one of the ways it's kind of, if you have to translate this to people at home, now how do you do that? Well, we're, as facility people, really, and power people, really focused on protecting the power to your desk, not the PowerPoint on your desk. Anybody like that one? No? All right. Okay. So this next part is going to be pretty technical, because I know people have been wanting to see that. But before we get going, I did want to show you a kind of a fun video of a Dutch gentleman who thought it was his job to teach people how easy it was to do just some of these events.
Aanpassen. Betekent dat ik straks de lichten kan uitdoen?
We don't have an interpreter here, so don't worry about it. We'll get the message here from his iPhone.
Het werkt! Kijk eens, 5 uur jongens, hup, tijd!
And it's a longer video, and he actually he fills up the screen, you can see the code.
Zie de Rembrandttoren daarachter, hoogste gebouw van Amsterdam. Genoeg licht om uit te doen. Komt-ie. Kijk nou, ik zet hem weer aan.
The gentleman's name is Max Cornelius, and so he was doing that for a little while until he was finally taken in by authorities who were not agreeing to that. But we'll get to more on that later. But again, as I said, this session is going to be very technical, and some people, I don't doubt anybody being able to keep along, but some may want something to help them understand the information even easier. So what's available is underneath some of your chairs, there are some glasses that will help you interpret this information a lot quicker. Seriously, there are glasses underneath some of your desks, not all of yours, but you can reach underneath. It's not a joke. They're real technical improvement glasses underneath your desks, your chairs. All right, so you risk not being able to. All right, there we go. We have a pair right here. You can display them. There we go, just like that. All right. No, they really work. I'm trying. Okay, it's not working. Okay, so here we go. I'd like to introduce Dr. Mike Chipley, who's been involved with this for many years, and very happy to have him on the team and presenting here today.
Good morning. We'll try not to make it too technical, but I do want to tell you that what we're going to see today are real-world, open-source, free tools that both the good guys and the bad guys use. And so tonight when you go home, you say, honey and the kids, look what I learned today. And you went one mouse click too far, and a bunch of guys in black suits and sunglasses show up at your house, and your name's on the news. This is where you learned it. Okay. So we're going to use a number of terms. As Daryl said, we're going to call this industrial control systems, and a little bit later you'll hear from Keith Stopper from NIST, who's the lead author of the Industrial Control System Security Guide, which is really now going to be one of our solutions to how do we go out and cybersecure these systems. You'll also see some emerging terms, cyber physical systems, the Internet of Everything. Again, we are now moving into the next era. As Dave said, we went from electrical, mechanical, and pneumatics and into electronics, and now we're moving into the next iteration of that. For us, we need to be able to define what we're going to try to protect. Okay, so again, within a given building now, there are many, many subsystems. In the days of when it might have just been an HVAC system, a lighting system, and a fire control system, an elevator system, again, since 2005 in particular, now, if we got a high-performing smart green building, you're going to have anywhere from 15 to 20 of these systems, and they are all interconnected. And as Louis said, most of these now are connected to the internet, and most of the owners don't realize that. So if we look at what a typical architecture is, again, we've got a number of vendors out there. In the case of a building automation system, you see then that we've got things that look like internet stuff. It's got IP, and you'll see the protocols HTTP like you normally use for your web browser. But then when you start getting into the building itself, and you see all sorts of funny looking devices, and these are building controllers and facility controllers of different types, and then they use different protocols. You can see there's one up there called Building Automation Control Network. We've got one called Modbus. We've got lawn talk. So we got lots of different languages that these components and devices now speak. And we have to understand what that language is. Here again is another tritium product. DoD uses Johnson, Tritium, Honeywell, Eaton, Schneider, Schweitzer, lots of the vendors. As Mr. Conger said, we have a very, very diverse portfolio of industrial control systems. And in one building alone, you could have 50,000 to 100,000 of these devices in one building. So the magnitude and the enormity is truly orders of magnitude larger than our traditional IT systems. Okay, so we have to, again, know what we're talking about. Is you can see here, we have JACE boxes, field servers. These are more or less where the facility point of connection occurs, where something's now plugged in at the building, and the rest of those devices are plugging into it. And then as you can see, we got a variable air volume, lawn switches, remote servers, and ultimately, those are level 2, level 1 devices. And ultimately, it's got to get down to something that is going to have wires coming out the back end that's going to make a valve or an actuator or something either move or turn on and off. Okay, so these are going to be our level 0 devices. And as I mentioned, they use different protocols up at the system operator, the console level, where he's managing that human-machine interface. They're going to use that standard HTTP web browser that we saw earlier. But then once it gets into that facility point of connection, notice now we have lots of different ports and different protocols that are used here that the IT community typically does not see. And since we've got some of our IT colleagues in the room, what is the standard IT protocol for all ports and services that are not on the authorized registry? Josh. Okay. What's the standard IT process for identifying all ports and services? Right. So in the IT process, it's deny all by rule. And open by default in your case. Okay, so if everything's open by default, then that means, as Louis pointed out, there's multiple avenues to approach and exploit those systems. Okay, in the DoD process, it is deny all by default unless it's explicitly identified. In this case, port 502 for Modbus. If Modbus port 502 is not turned on the firewall or switch, then that service is not going to run. And what happens when the IT folks go out and find things that look like IT equipment in the telecom closet, and then they say it's not on my authorized list and it's not on the authorized ports, they turn it off. And so that's what we'll start seeing more and more. Again, inadvertent consequences of not having the CIO and the facilities and the physical security folks now having this joint conversation. Okay? Fundamentally different. Most of these systems operate off of what were called masters and slaves. Again, that Modbus and BACnet architecture, one master controls lots of slaves. And now we're now moving to Bluetooth and Zigbee, which again now are peer-to-peer. And you can see the different file extensions over there. As Louis pointed out, we were going to exfiltrate data. We're going to go change these project files to change the firmware that's embedded in them. And then we have a little bit different terminology. Instead of it being a hard drive and a read-write to your hard drive or your portable media, we use what are called registers and coils. So when you see the exploits going forward, when we show Shodan and some other stuff, Modbus, look for registers and coils. That's, again, different terminology. So here's some of that architecture, again, that you can see. The Modbus client is talking to lots of different slaves. And then you can see it's got RS-485 cables and perhaps some RS-242, some other different kind of cables. It's not your typical Cat5 or other wires that you would see going from an IT system. These, again, are specially designed cabling and protocols for these devices. Here's a typical BACnet architecture. Again, building automation control. And all of these protocols, by the way, are clear text, open, with no encryption. They were always designed to be made for the maintenance technicians and always have these systems on and available. And so now going backwards and trying to put in place encryption or security on top of it is problematic. And Louis showed, for example, an appliance called Torfino. Well, that's one of the ways you can start subnetting these networks, putting appliances in front of them so that we start now getting that system isolated. So if something happens introduced on the access control system, it's not going to automatically jump over to the energy management or the emergency power supply. Okay? That's one of our objectives going forward. Here's what we're going to call our reference architecture. And again, you can see up at the top is that internet connection at the level 5. At level 4 is where we've got our console operator running a Windows or a Linux box, but by and large, almost 90+% are Windows boxes. And that's where that HMI is going to be resident, that the operator is going to manage. Level 3 facility point of connection still looks like mostly IT stuff, switches and routers. But at that point, it's where we transition into then running those internal building controller devices at the level 2, level 1. Again, one of the things we want to be careful here is at the level 4 and 5, active scanning using products that most of us are familiar with, like McAfee and Norton, Nessus, those work fine. We do not want to apply active scanning in those building level devices because, again, they're not made for it. So we have to use passive detection means. And again, there's only a handful of products out there now, but that's where the technology will rapidly change. The attacker, on the other hand, can attack through any of those means. He can come in from the top and drill down, or they can come in the middle and go up or down, or come at the bottom and go up. So again, we have a much more difficult challenge to identify all those exploit vectors and then protect them. Okay, here again, some of our tools that we'll have at our disposal. We're going to do a real quick examples of Google hacking, Shodan, and Wireshark. And then later on, you'll see from Department of Homeland Security the Cybersecurity Evaluation Tool. Again, another key tool in our arsenal for us to start working with architect, engineers, system integrators. Okay, how many folks have Google hacking? Let me see a show of hands. How many folks have heard the term Google hacking? About a third. Okay. Again, it's taken the advanced search capabilities of Google and Bing and other search engines, and then you're just going to manipulate those search operators to start identifying targets of interest. And in this case, we've gone and just done a very quick search on Navy plus Tritium plus Bangor. And you can see then that it takes us over to the Naval Engineering Contracting Office. And if I do a different search, you can see I've got site.tritium.com, and I want to look at that site for anything that's got a .mil address in it. Again, it's not on the Navy's website, it's on the Tritium website. And so does the Navy know that somehow they got cross-linked into one of their very far-in deep sites where this solicitation was posted? And as you can see, it's the Modernized Industrial Control System for Naval-Based Kitsap. This solicitation had down to the building, room, and device number with the firmware version identified in the solicitation. Okay, so Mr. Conger talked about changing our enterprise processes. This is where we've got to rethink how we do acquisition and contracting, and that we need to now have a place that the contracting officer says, you're a validated vendor, supplier, contractor, here's a secure site, this RFP will only be available to you if you're registered for that particular RFP. And again, so now getting these things out of the public domain is going to be part of our process of evolution. Here's a new tool that's been out just recently called Diggity. And again, you can see here what they're saying is sometimes the most offensive defense is an offense. And so here's a tool now that you can use to start looking at your systems and get an idea of what is out there for your sites. It's a nice little graphical web interface versus the Kali Linux tool that I'll show you in a little bit that's a Linux. But again, now it lets you do Google hacking, code searches, Bing searches, Shodan, and you can see here, if I go click on to one of those web IP addresses, which we're going to show here in just a second, it's going to take me right into their HMI. And how many of these vendors or owners do you think know that their systems are completely exposed on the internet? Shodan will find these, and it does not take long for it to become into their database. Okay, how many folks use Google Earth? or GIS platforms, okay? Again, a great tool for now visualizing. And so whether or not you've got Google Earth or Bing or other geospatial applications, most communities now have an association with their Google or their GIS KMZ files that then you can download. So you can see, for example, here in the District of Columbia, all the different types of publicly available information that allows an attacker now to footprint that facility. So I can identify remotely now pretty much every avenue of infrastructure, that how the water, power, gas comes into a facility, what its distribution might look like. And then again, if I go in with Bing and Bird's Eye, we have extremely high resolution orthogonal photography that then you can use to, in some cases, get down to, you can read the vendor tags. And then if I go into Street View with Google, again, very high resolution imagery, 360 degrees. And so again, I can very quickly now remotely footprint that organization and its critical infrastructure, its facilities, and most of the systems that are going to be identifiable from the outside. Okay, Lewis had mentioned Shodan. So very, very powerful tool. It is to find IP devices, anything that's online, as you can see, webcams, routers, power plants, iPhones. If it is an IP connected device, it will find it, and then it will display a tremendous amount of information. It is real time. Unlike Google and Bing that use spiders to go out and search, Shodan is real time, so it's constantly changing. But once you've found your target of interest, then you've got it. Let's go back. Up here on the top left, you see where it's got exploits. Again, these tools are for good or bad, and so it links right over to the exploits database. So if I have a vendor and I want to now look up a particular vendor, an IP address, a product line, now I can go into the Google hacking database and, in fact, grab that exploit. So if I identified a Honeywell, a Siemens, a Tritium product line that's out there, very quickly now I got the exploit, and when I want to run that exploit, we'll use the Kali Linux tool. We'll identify it. Here's our homework done for us. Okay, so what does Shodan actually show you? Here you can see up at the top, it's going to tell you what services are running, which countries it's in, which top organizations, and you'll see now the IP address, and you can see here it's saying Tritium with the version number, workgroup numbers, MAC addresses. We'll actually be able to find firmware, subnets, and as you can see here, if I click on that particular link, it takes me right over to a human-machine interface login. Okay, again, do you think most of these companies or property owners realize that they have directly connected their primary login screen for the entire building control system directly to the internet? Okay, let's look at, and yes, in fact, most of those will have default passwords. So if we go to another website called defaultpasswords.com, and in the case of, let's say, the Tritium, if it was 3.5 and earlier, the default passwords were hard-coded in. The system integrators had to make that change, otherwise default stayed in place. And again, that's what the hackers are looking for. And then again, social engineering a attack against that facility engineer or that organization to capture those credentials is not that difficult as well. Now, Distech is a building control device manufacturer. Again, those level 1, level 2 type devices we talked about. And again, remember I've talked about the different project files and firmware that those systems are going to run. Here you can see, again, I've clicked on that. Now I've got the Niagara admin. I've got an algorithm for the encryption software. There's the hash. It's a Niagara platform QNX. It's a Distech brand. Here's my host ID. It's running Web Server 3.0. Again, most of the information needed to start compromising this system and these devices has now become easily gleaned with just a few minutes of Shodan searching. And for those folks that would like to see hands-on, Dr. John Saunders from National Defense University is here. He's got an outstanding lab right here at the NDU campus where he demonstrates hands-on with a lot of these techniques. Okay, how many folks have heard of Kali? All right, we got about half the room. Okay, so this is the Hacker's gold standard tool. It's a Linux-based platform, and what we want to do now is start to have, as part of our contract and acquisition process, making penetration testing a part of, for particularly high-value critical systems, that good guy hackers come in and run these tools and evaluate your system, and then identify any potential exploit vectors, and then mitigate them. Okay, so Kali, again, open source free tool, but it has a tremendous number of exploitation tools. As you can see, everything from network to information gathering, vulnerability analysis, password attacks, wireless attacks, social engineering. The exploit database is there, and Metasploit is the tool that we would typically use to actually go out and do most of the actual penetration hacking. So just be aware that your toolbox now for your IT/facility folks, we want to have Shodan, Kali Linux, Diggity, and the CSET tool. Those probably are going to be your 4 basic tools that you want to have in your toolkit. Okay, here's the SANS poster. It looks very similar to our earlier architecture definitions, but if I wanted to now target this, this would be the sequence then that we would come in and use different types of exploits to actually then start at the top and drill on down. And Metasploit now has Modbus modules built into it. I think they're starting to see a few of the BACnet and LANTalk and other control system protocols. So again, Kali Linux continues to evolve, but recognize now that there is a mechanism for the bad guys to identify the Modbus devices. So in fact, if I got all the way through that attack sequence, indeed here I've gotten all the way down, and now I've identified what the master Modbus IP is and the slave IP addresses. Okay? Okay, another tool, 5th tool that we want to make sure we have in our toolkit. This is software testing for utilities, Samurai STFU. It's specifically designed particularly for smart grid, smart building, and advanced meter infrastructure penetration testing. And it has, again, a number of field technician interfaces, RF communications, embedded electronics, specifically for those building control, field control devices that we talked about earlier, versus Kali, again, is more the IT side of the house. So again, highly recommend that this become part of your toolkit. It's got another tool in here that, again, open source MBT Git. It is a Modbus read-write capability. So earlier when I showed you how